Alright, so define the variable space. X1 is equal to number of pounds of chicken, and X2 is equal to number of pounds of beef. Objective is to minimize costs, and the costs are given here: $3 per pound and $5 per pound. So we can write down minimize Z is equal to 3x1 plus 5x2. Okay. Now the recipe requirements are, these are the constraints coming here. In fact, the first constraint is that hot dog mixture is in 1000 pound batches. So this means that x1 plus x2 should be exactly equal to 1000. Okay, so this is an equality constraint here. Subject to, the first constraint is that this mixture should be in batches, and batches of 1000 pounds. So x1 plus x2 should be equal to 1000. This is first constraint. And you can see that this is an equality constraint. It's not greater or equal to, not less or equal to. The second constraint can be seen from here. Other constraints. At least 500 pounds of chicken. At least, which means it can be greater or equal. So we can say x1 greater or equal to 500 pounds. Alright? X1 is also in pound, the right side is also in pounds. And then we have the 200 pounds of beef. X2 greater or equal to 200. Another constraint is there. Ratio of chicken to beef must be at least 2 to 1. So x1 over x2, and again it is at least, which means greater or equal to. So greater or equal to 2 over 1, 2. Okay?
Yes.
Now, if we have to give it to solving for Excel or some other program, we require that the right hand side should be some value which is there, but not in this format. So what we can do is we can have this in the format x1 greater or equal to 2x2 or x1 minus 2x2 greater or equal to 0. So this is the standard format to write it. For example, if we want to solve it by solver in Excel. Next time we will talk about how to solve it in Excel and QM for Windows. Okay? So this constraint, the last constraint is x1 minus 2x2 greater or equal to 0. And of course the final constraint is non-negativity constraint. Although this is a redundant one because x1 is also greater than 500, greater or equal to 500, and x2 is also greater or equal to 200. So this constraint is redundant, but for completion's sake, we will write down also this non-negativity constraint. Clear? Any questions on this formulation? No problem? This is the formulation. Here is another example for solving it with the graphical technique. Just the problem is given, draw the graph and solve it. I will just quickly go through this. You solve this, you make these constraints and find out the feasible region. The feasible region is in this, what we call this one? This figure, how we call this? Polyhedron or this one. Anyway, this one is the feasible region. Okay, and you just work out these corner points here, 1, 2, 3 and 4. Work out the profit at each. This is a maximization problem. Work out the maximum at each point, the profit, if it is profit of course. Then this is the solution here, and now I will ask you one more problem. Since we have little time, more time, we can have this okay, please see this one. There are some special cases in this one. We discussed special cases: unboundedness, multiple optimal, and infeasibility. So there are 4 formulations. One of the formulation is correct formulation. It can be solved. It doesn't have any special case. The other 3 formulations have special cases. So please look at that, draw the constraints and see what are the special cases. Draw the constraint quickly. You don't have to solve them. You just draw the constraint and you can see by drawing the constraint that what are the special cases are there.